We have with us Praveen Katpal, who's the Vice President of AES Energy Storage, and Eric Ellis, who's the Manager of Technology Assessment and Integration at APS, or Arizona Public Service, right? One of the largest utilities in Arizona. So before we get started, right, I do want to sort of set the context straight here. We were at not this exact venue, but a venue across the road last year this time, when I think AES announced its first project with APS. First two projects, I should say, there were two batteries that they announced as part of APS's Solar Partner Program, and we're exactly 365 days out since that announcement. So let's sort of use this platform as a sort of as a context of what has changed in this last 1 year in the industry. So Praveen, I would like to start with you. Here we are since exactly a year since then, and since then actually you've done several more projects. You did bring the Escondido project online, which was then the largest lithium-ion battery system in the world, and very recently the Tesla project got that title. But anyhow, let's think about what are some of these most sort of significant developments in the industry since that first announcement a year ago.
Sure. Thanks, Ravi. First of all, I'd like to say it's been an absolute pleasure working with Eric and his team at APS. And you're right, it was at the same event a year ago that we announced our first pair of deployments that we were supporting APS on, and really excited to be here talking about the next one. And I think Eric can provide a little more detail about that, but what it represents for us is continuation of storage going from one part of utility planning into another. Where last year we were talking about a project that supported renewable integration on distribution feeders, and now we're talking about storage that can defer or substitute for a significant transmission and distribution upgrade. And the same way that earlier this year we announced our next collaboration with San Diego Gas and Electric, where the project you referenced in Escondido and its younger brother that we built earlier this year were built for one purpose, but we're now continuing to support San Diego Gas and Electric to meet a local capacity need. So all of this really ties in to what's the big development. I think Stephen and Shale really nailed it with their various metaphors. But the core theme, I think, is storage going from being niche to becoming elemental to grid planning. It's becoming a fundamental and essential aspect, and it's showing up in more and more places. I'm not quite going to liken it to velociraptors, but I did like the going from the bench warmer shooting free throws in his parents' backyard to really getting in the game. In fact, earlier this year, when my son turned 1, we got him an NBA-sized basketball for his first birthday.
Wow!
So he can start down that
early,
path.
Yeah.
But that theme of it going from something that's really on the sidelines to something that's in the spotlight, I think has been the prevailing theme of the last year.
Got it. Great. Eric, I think Praveen did allude to the Pumpkin Center project, which is what being used for T&D deferral. So that again is a great example of how a utility can utilize non-wire solution and to an otherwise extremely expensive transmission upgrade. Can you sort of talk about what are some of the other applications? Because I think we want to avoid saying the game that you can play with Jenga with multiple values. So how are you using the storage asset, or plan to use storage asset, I should say, beyond just the core transmission upgrade or deferral that you expect?
Yeah, probably most of the people in the audience are just familiar in terms of Swiss Army knife. You've got the opportunity for storage to provide capacity, arbitrage benefits, frequency response. You mentioned the Pumpkin Center project, and that's a 16-mile, 21 kV distribution line deferment that we're working on. And so we're really focused on executing that project and just really proving out all of the things that are needed in a utility integration like that. It's one thing to talk about doing deferment. It's quite a different thing to put it into practice. And but I want to come back to your question a little bit in terms of what are the kinds of applications that we're looking at, and we're targeting in sort of late 2018, 2019. Wanting to see storage distributed in such a quantity across, say, a single feeder in the right locations, in the right sizes, so that we can get a good uniform distribution of storage across a feeder, so that we can start to exercise some full voltage and VAR control over the feeder from a single deployment of storage on a feeder. And we think that if we can be successful in doing that, and that probably involves, say, 1 to 2 megawatts of distributed storage, and we're thinking nominally sort of storage units in the 200 kilowatt size range, so we're talking about 5 to 10 different storage units deployed on a single feeder, which poses a whole variety of challenges. And from how do you site these units, where do you put them? Because they need to be in the right locations. Right. But if you can get them in the right locations and in the right quantities, you start to enable then new opportunities for value creation, the opportunity to work synergistically with existing line devices, regulators, and cap banks to just solve voltage problems and create value in a new way. So that's one of the things that we're looking at. We think that the industry has some potential also to bring some new kinds of products in that sort of niche, because a lot of the products have been focused on bulk storage, and they've been focused behind the meter storage. But there's a third arena that we can talk about, is how do you get storage into the distribution system sort of in the 100, 200 kilowatt size range, and then network them all together under a single controller to achieve sort of just a new means of really sort of providing some very nice benefits to your customers, and doing that all in a way that the complexity isn't off the charts. I mean, everyone's talking about putting all these devices behind the meter, and they're all going to do these great things. And our work, and we've done a lot of this in that arena, has shown us that that's a very hard thing to do. To put units behind the meter. I mean, certainly if it's providing a single benefit for a customer in the form of a rate, that's that makes sense, and where the rates line up for the customer, and the customer wants to make that investment, then have at it. But to be able to unlock this sort of full potential of DER, they need to be really sort of intelligently coordinated, not just from a real power, but from a regulation and VAR perspective. That only happens, if you have a handful of devices that you can invest in, get the cybersecurity and the controls and the alarms, everything just right. So we're working on that. That's an area that we're focused on for 18 and 19.
Got it. So you did mention that it's harder to think about behind the meter assets, providing grid services, although APS is looking to come up with rate designs that would encourage more behind the meter storage. Mm-hmm. Can you talk about the recent RTEC rate that APS just launched or proposed to the commission? What's the rationale behind it, and what do you expect coming out of that rate structure change?
Yeah, so with respect to the RTEC rate, so what's really focused there is, all utilities face this challenges. We really need to get rates fully aligned with the wholesale markets. And so the RTEC rate is intended to really sort of fully achieve that. So it's a demand-based rate where our customers are on that need to have advanced technology. They've got to basically be on they're going to be incentivized to avoid using energy in the 3 to 8 o'clock window, which is when our system in the summertime is seeing the absolute sort of peak needs. And the RTAC rate is designed to finally fully incent customers to avoid using energy during that period of time. And if you can do that with a combination of technologies, be it smart thermostats or residential energy storage system, or solar or other kinds of load management devices, then it's our way of really embedding in the rate structure the right kinds of incentives, so that instead of a traditional net metering structure where energy is just delivered and somebody else is really sort of still doing the incentive somewhere else, we're trying to put the incentive fully within the rate structures and align, how the customer is using his or her energy with what the system needs.
Got it. So Praveen, AES of course is not so much into behind the meter storage. Most of your work has been more on the front of the meter side. So taking in sort of some of the applications that Eric was talking about on front of the meter side. As a storage service provider or an integrator, what are some of the challenges that you face when you're thinking about all these multiple value streams, and are they more on the technology side? Are we at a point in the industry where the technology is capable of providing these services, and is it just a regulatory issue, or what are some of the barriers that exist in the industry today?
Well, first of all, it was really impressive how you avoided using the word stacking in that question.
Twice now.
Given what happened on our first session. No one's run for the doors yet, so good job. I think there's two levels to that question, the technical and the regulatory. We always try to think of it as if you stack it too high, it falls over. So first of all, the world is ripe with single-use applications for storage. That realm, there's still a lot of low-hanging fruit. It hasn't been fully exploited. So completely resolving this is not a barrier to growth in the industry because that's happening. When we start talking about multi-use applications, I think sometimes the industry turns a little too inward because it makes for a really interesting engineering problem. It makes for a lot of great white papers and a lot of really good work for the analysts and the consultants and the lawyers out there. But when it comes down to it, if we just draw parallels to other things that already exist in the power system, this has been happening forever, right? No one, and many of us have experience in conventional generation. I've never heard anyone who's developed a gas plant talk about value stacking, even though they're fundamentally building something that can provide capacity and energy and ancillary services, and in some cases even gets paid for network support based on its locational value to the T&D system. It's problems that there are already mechanisms to solve. We see that happening. We see this coming up more and more, basically, where a wires utility regulated use is being matched to some other use. And again, this is already happening. It's happening in demand response, energy efficiency, and other customer-side technologies where utilities are co-funding devices that customers buy. So it serves a utility use and it serves a customer use. We see it all the time with utilities crossing over with telecom. When you have a regulated rate-based transmission tower that's leasing the very top of it for someone to put a cell phone antenna on, or utility-owned fiber networks where the excess capacity is being leased off. So it seems to have struck a hot button where the crossover use touches on wholesale markets, wholesale power markets. And I think if you look at any of those other examples, really what the utility, the regulated utility use has provided to the other sector is a lower cost way to serve their customers. I think very few people have cried afoul about this distorting the market for thermostats or fiber capacity or things like that. So I think at some point we're going to have to become comfortable in the next iteration of this industry that price spikes in wholesale markets are no longer going to be an effective way to motivate generation investment. That may be the larger scale hurdle that we have to get through on a regulatory, on a systemic basis. But certainly when it comes to exclusive use of a single asset for two different purposes, we believe that's something storage can do and follow the models that have already been laid before us.
Got it. So one of the questions that the audience has asked is more around bankability hurdle, and Eric, perhaps you can address it. So how high is the bankability hurdle when selling against your competition? How do you combat it? Or in other words, I think this again gets into the regulatory versus unregulated side of the business, which APS doesn't have to necessarily deal with. But is bankability a concern about the technology today, and how do you go back and talk to your stakeholders and convince them that storage is ready for that challenge?
Yeah, so there's a couple of different ways of thinking about bankability. So, obviously, if you're a developer of storage assets and talking about raising third-party financing, it's pretty clear what people are talking about with respect to bankability. And so I work for a vertically integrated utility, and so we think about that question in this manner, which is, we're now getting to the arena where we're using storage, and these are no longer demonstration projects. We're out doing real projects that have real reliability purposes for our customers, and that are going to be forming both local distribution services as well as bulk capacity services and things like that. And so we absolutely need to have counterparties, and one of the reasons we've selected AES is entirely for that bankability concern. Is we want to deal with entities that we know are going to be there, and that have the sophistication and the willingness to stand behind all the performance guarantees that are going to be required. I mean, so when you think about things like availability, and you think about things like round trip efficiency, and does it provide the voltage regulation services, and all of the thinking that goes into that, we are looking for an entity to step up to the plate and say, yeah, we're going to be there side by side with you, and we're not technology experts. And so, we run a bulk electric system, and we know that the suppliers are technology experts, and so the kinds of the solutions we're looking for are from people who are experts, or entities that are experts in their technology, or are willing to put their balance sheet behind it and be there with us so that we can protect our customers in the event that an asset doesn't perform. And so, long-winded answer saying bankability is extremely important, and we consider it very heavily, particularly as we move from smaller kinds of applications where we're trying to understand exactly how to integrate the storage into our system, to the storage doing real bona fide services for the utility that our customers count on us to provide.
Got it. So Praveen, one of the, I believe, rationales for Siemens and AES deciding to form Fluence. It was clever, by the way, having Fluence 2018 as the password for the internet today. But anyhow, how do you sort of see some of those concerns being addressed as your team is moving towards that formation of that entity down the road?
Yeah, and this ties exactly into what Eric was just saying, as well as that theme from storage going from niche to elemental to grid planning. And that's one of the reasons that AES and Siemens are partnering together to form Fluence, which is going to be a joint venture, an global energy storage technology and services company, launching at the start of the year. We saw things going in this direction, and storage being more and more needed for real reliability purposes, and that coming up in more and more places. So, working with a partner like Siemens, where they know the customers through their sales force in 160 countries. They're very close to utilities and the industrial customers we're going to be selling to, and they know the problems too. They're actively engaged in studying those grid systems. So from a sales, from a service, financing, and bankability standpoint, Siemens is a great global partner for AES to join with to address that market.
Got it. Great. Eric, I have a question for you, which has been voted up. What makes Arizona different when it comes to energy storage? I'm assuming this is again going to get into some of the conversations we've already had around regulated versus deregulated entities. I have a slightly different twist to that question. Hopefully you'll get to answer both in the same response. But APS, when it released its most recent IRP, or Integrated Resource Planning document, you have a fairly sort of lofty goal in there of having 503 megawatts of storage onto the APS system from 4, which is what is operational right now. So when you think about what has sort of triggered or changed in the last few months that has made APS so confident or bullish, if I can use that term, in terms of how it views energy storage?
Well, there's nothing magic that's happened within the last few months. I mean, we need thousands of megawatts of new capacity We've got major contracts rolling off in the 2020s, and we have also, growth in our region because people continue to find the Southwest an attractive place to live. And so in our forward planning models, we just, we need a lot of new capacity. So for a number of years now, we're going out in our third year in a row, we're going out for hundreds of megawatts of new capacity. And so we have had the opportunity to see, what's happening with respect to where the market's going with its perception and belief and forecasts on where storage is going. And so we've seen, and so this is also the domain of our resource planning team. And so, within the technology assessment arena, we work pretty closely to support them. And so, so what we're seeing is very sophisticated companies, with the kinds of balance sheets and track records that, we know that when we see a number of very sophisticated, credible proposals that come through, and we've seen that over a trend line. And so we've also are talking to the technology solution providers themselves, and so this is a bit of a, it's a bit of a prognostication, it's a bit of a forecast. And so we're only going to make decisions. And so an IRP is sort of a view. It's a forward view on where do we think things are going.
Right.
And in terms of what we're seeing, it's promising. But there's kind of conflicting data out there also, because on the one hand, we see the trends and we see the kinds of sophistication of the parties that are showing up, and that gives confidence. And we also talk to solution providers, and a lot of the solution providers have told us a little bit, some caution coming forward in the 2020s. That potentially lithium-ion battery storage costs aren't going to be coming down at the same clip that they have. And at the same time, we look back and we see, sort of the kind of innovation cycle that's occurred with wind, the innovation cycle that's occurred with solar, the innovation cycle that's occurred with storage, and we ask ourselves the question, is that going to continue? And so, we're a company in that we are definitely pro-technology. We see what it can do. We have a commission that's very supportive also of and encouraging of wanting to see us get more storage into our customer locations, see us deploying more storage, and then we're also getting this sort of very good trends in the technology. But in the end, what has to happen to sort of fulfill on that is that those trends have to continue. Right. And we need to continue to see the same kinds of parties with sophisticated offerings that are backed by sizable entities to sort of make good on that goal. But a bit of a long-winded answer to saying that those are sort of all the confluence of events that are informing that view.
Got it. And Praveen, as a service provider, do you see any pitfalls to that view, or are you expecting that the cost declines will continue and the industry will sort of end up deploying and basically delivering on these promises?
Yeah, we absolutely see the cost trajectory for lithium-ion continuing. I would say that if I'd been in the previous session and been asked what my storage technology spirit animal is, it would be good integration.
Okay.
Because coming out of the power and utility space and becoming an integrator as we have, we really approach the storage technology space from a technology agnostic perspective, but we always say that we're agnostic but opinionated. And from doing the first megawatt scale lithium-ion installations 10 years ago, today, we've seen that technology become dominant. But we're cognizant that that may not always be the case, and that's why we've created a controls platform and an architecture that remains abstracted from that technology layer, so that it is forward compatible with technology change.
Got it.
So that if we're in year 11 of a 20-year project, and lithium-ion is no longer the ideal technology match, we can augment that system with whatever the technology of the day is, without having to do a complete gut repower like many of the other integration architectures out there would need.
Got it. And is that a function of the, again, if I understand correctly, the way you balance voltages or make these assets more sort of more modular, or what will enable that kind of augmentation, even if you were to go beyond lithium-ion? on the hardware side?
Yeah, so it comes from several of our design criteria, including modularity and abstraction in the controls from the technology layer to the application layer.
Got it. Great. So there's a question out by the audience. We probably have time for maybe 2 more, but how do grid operators ask for services they need in real time, and is the price signal part of the protocol? Either of you want to take that question? I'm not sure if I'm assuming neither of you have worked at an ISO, but can you sort of try to shed some light on how do grid operators usually ask for services, and how is it sort of priced into the service?
Yeah, so it depends service to service. So where we started in doing frequency regulation in U.S. markets, there's a dispatch signal. There's an AGC signal that translates the grid need in terms of the frequency and the area control error into dispatch for each resource that's providing that service. That's one way of doing it. We've also deployed arrays that can run in an autonomous mode where they sense the frequency, changes in frequency, the rate of change of frequency, and respond accordingly. And we've developed some IP around that type of response as well. But this question, I think at a higher level, is really about storage controls, and that's definitely one area where I think we and APS have learned a lot by working together, both of us, in how controls need to work. And having a really flexible application layer to the controls at the array level or the fleet level is critical, so that it can enable controlled dispatch, or it can enable autonomous dispatch subject to various data feeds of conditions external to storage.
Got it. Got it. So Eric, as a regulated utility, a lot of this is essentially done in-house within APS. Can you sort of talk about how is the sort of the NOC, does that look different from an ISO's NOC in this perspective in terms of the signaling as well as the response that you expect from these assets?
Yeah, so unfortunately I can't comment on what an ISO NOC looks like. I mean, I can answer a little bit from the perspective of, so when we think about sort of, in an attempt to answer that, sort of the question that you just posed, I mean, we try to quantify what those benefits are ahead of time. And so when we're looking at a particular application, we think about the services that we need from the storage, and then we're going to work with the supplier. And Praveen mentioned this. We're doing a lot of work with AES to understand, how can we put a particular battery storage unit in power factor regulation mode, or in voltage regulation mode, or put it in a frequency response. But we've got to be really sort of thoughtful in terms of when we put it into a schedule for a given week. We're going to prioritize the functions. I'm going to use the stack word. We're going to stack them. What's going to be primary? What's going to be secondary? So our thinking on that really sort of is on the front end, because we're a vertically integrated utility, and then we're going to simply schedule the unit according to the services that we needed to sort of run, and that all happens within the operations center. We're doing as much work as we can to sort of integrate that for our operators, because one of the big challenges in the industry is, once you start to sort of proliferate all of these different storage devices, how are you not going to drive your operators absolutely crazy? Right. How are you going to give them a nice, clean, uniform, single pane of glass that they can sit down and the interface looks the same, whether or not you've got an AES unit or a Lockheed Martin unit or a Unicus unit, you name it, you pick your vendor, and it all looks the same and the interface is the same. There's a lot of work still needed in terms of standardization and open standards, communications, and protocols, related to how you actually make this work for a utility operator.
Got it. Which, of course, is the more boring but necessary
element
of the industry.
Well, I don't know. It depends.
Excellent. I think that's all we have time for. So I would like to thank Praveen and Eric for sharing their insights on the role of storage.
Thanks to you, Abby.